The El Niño Southern Oscillation, or ENSO, is a climate pattern where the ocean and atmosphere talk to each other. This affects weather all over the world. The atmospheric part of ENSO has its own name, the Pacific Walker Circulation.
One of the biggest drivers of global climate is the Pacific Ocean. The reason for that is because the Pacific Ocean is really enormous. It's way bigger than any of the other oceans. And this sets up some really interesting climate patterns that have a very big influence on what happens in the rest of the world. In this Nature paper, we looked at hundreds and hundreds of years of data to tell us how the Walker circulation has behaved differently in the industrial era compared to the hundreds of years before that when humans hadn't affected the climate system. We had this really interesting finding that the Walker circulation might be slowing a little. And so what that means is that instead of quickly flipping between El Niño-like and La Niña-like conditions, those would tend to last a little bit longer. I guess as we've seen in Australia in the past few years, where we've had 3 La Niña years in a row, this has been associated with really heavy rain, for example, the flooding that we've seen on the East Coast. Our research suggests that these sort of multi-year events where we get maybe 2 La Niñas in a row or 2 El Niños in a row, these might become more common. We actually use data sources from all over the world. China, North America, we even use data from Antarctica. Even if there's just a little bit of information stored up in an ice core from Antarctica or a tree from China, just a little bit of information about the Walker circulation, we can extract that and use that to help us figure out how the Walker circulation's changed over hundreds of years. We know that the Earth is warming and that this is the result of human activities. Given this, it was actually really surprising in this study to find that on the whole, the strength of the Walker circulation is no different in the industrial era to how it was in the pre-industrial. This was surprising. What we did find is actually that the human-generated aerosol emissions, so things, for example, from coal-fired power plants and car exhausts, they can actually cause the Walker circulation to get a little bit stronger. The other really fun thing we found is that major volcanic eruptions actually cause the Walker circulation to get weaker for a few years, so an El Niño-like weakening of the Walker circulation. Look, as a scientist and a person who just loves the natural world, I love volcanoes. So the fact that the eruption of a volcano can cause the Walker circulation to get weaker, I thought that was really cool. I mean, a volcano goes off somewhere and then we have these El Niño-like conditions.